We will now continue with our next polynomial long division problem, and we will continue after that with 4 more examples of various types of problems you might encounter. For this particular problem, we are doing x cubed minus 4x squared plus 2x minus 5, all being divided by x minus 3. So we want to set it up just like we did in our previous problems, like a long division problem, and we're going to be doing the division steps over here to the side. So we have x cubed over x equals x squared, and we can put that answer at the top, and then we are going to be dividing it using or multiplying it out, x squared to both of these parts, and getting x cubed minus 3x squared. We want to subtract that out, so we could put in a 0 right here for x cubed minus itself, and we could even put in a little minus in parentheses like that. And then a good strategy for most problems would be to kind of bring down everything on the sides, but generally you might only bring down the 2x. But it's okay to bring down both parts like you see in front of you. We then are going to proceed by just continuing on with the problem. X into negative x squared after we kind of leave our 0 right there. And then when you get that answer of negative x, you're going to do negative x times both parts over here and get negative x squared plus 3x. And then we're going to subtract those from what's above it, giving us negative x, and then we are bringing down the negative 5 since it was not used at all. And we have one more cycle of this problem left. We have negative x divided by x, and that equals negative 1. This negative x divided by this x. And we are dividing them and getting negative 1 up there at the top. And then negative 1 is what we're going to multiply by to get the answer underneath. So let's put that underneath there. So we have negative 1 times both of these. And then that answer gets put underneath. And we then have our last step of subtraction to do. And we get an answer of negative 8. And well, x can go into negative 8. So that means that we are done the problem. And we can write our answer, as you can see at the bottom here. And remember that this original problem right up here is equal now to what I have in my box answer right there. So in our next problem will be a little bit different, so we can kind of approach that in a different way. But looking closely at this next problem, we can see that both the numerator has a term missing. There's no x cubed term. And the denominator is actually a quadratic polynomial instead of being linear like the problems we just saw a moment ago. So the setup is the same, but we now put in a little placeholder right in 0, negative 0, x cubed right here is just a placeholder. But the problem is going to work the same. X squared into x to the 4th is our first thing we got to do. And we divide that out and put x squared. Something I want to point out here that is very important and good advice is that you want to have the x squareds or any other things that are like terms always stay vertical with each other and lined up. And that will make organizing your work much easier. So x squared is going to get multiplied by all of these parts on the left, and we're going to line them up with like terms. X squared times x squared is x to the 4th. X squared times x is x cubed, and x squared times negative 1 is negative x squared. And we're going to have to subtract these and get some answers. So we have a 0, x to the 4th. That's all gone. 0 minus 1 is negative 1. Negative 2 minus a negative 1 is negative 1. And then our x, we can bring down our next item. So now in the next part of the problem, you can see that everything just copied down. So now we have to do x squared is a negative x cubed. And we can do that division off to the side if we need to. And we get negative x, and that goes above the other x term that you can see right here. So now we have our negative x in blue right here that's going to get multiplied out. And so we have x multiplied by all three of these parts, and we can put our answer for that multiplication down underneath. Negative x times x squared is negative x cubed, negative x times x, and negative x times negative 1. And we have our answer for those three multiplication problems right there. And once we subtract that out, well, we get negative 3, because negative 3 is the only thing left. All three of those parts became zeros, and our remainder ends up being that negative 3. And we can see at the bottom that we have our answer. Our original problem on the left, our answer on the right. So we got our problem right here, and then this part on the right is our answer: quotient, remainder over divisor. So that was a pretty complicated problem overall, and let's kind of keep moving through some more examples here together. In this next problem, we can see the numerator is not missing any terms, x cubed all the way down to a constant. But the denominator is missing an x term, and that will be something you'll encounter. But it's not something to be worried about because the process is still the same. We're still doing 3x cubed divided by x squared right here off to the left, and we get an answer of 3x, and we want to put it right here above the other x term. So now if I want to multiply this out just like before, I want to just do 3x times both of these and put the like terms under each other. And so I'll do that, 3x cubed, and 3x is 3x times x squared and 3x times 1. But there's no x squared terms, so we're kind of just thinking there is like a 0 right there. And we can still subtract. Well, negative x squared minus 0 is the same. 4 minus 3 is 1x. Negative 1 minus nothing. Well, that can just get brought down. So from there, we're just doing the same thing that we were doing before. And we can do x squared into negative x squared as our first step. And that division gives us negative 1. So we're going to put our negative 1 over the other constant term right here. And that negative 1 gets multiplied by both of these and get our answer at the bottom. X squared under x squared, constant over constant. And we're going to be subtracting those to get an answer of just x. We have zeros in the other two parts because negative x squared minus negative x squared is 0. Negative 1 minus itself is also 0. And that means we have an answer at the bottom that has an x as a remainder, which is new, over our divisor. And 3x minus 1 is our quotient. And just like before, our original problem up here at the top left is going to be exactly equal to the answer we get at the end. And that would finish this problem up as well. We are now on our second to last problem. We are dividing x cubed plus x minus 2 by x plus 2. And we are going to be dividing it by a linear factor here. So that was more like most of the problems you're going to see. And I think we'll be getting a little bit more of the hang of it during this. So we'll go a little bit quicker through this problem. So we have x cubed and x as our first two terms. We will divide those first. And we get an answer of x squared. So we want to put it on top of the other x squared term, like so. And then do multiplication. X squared times x is x cubed, and x squared times 2 is 2x squared. We then subtract and bring down everything we haven't used. So we have a 0 right here, and both of these terms got brought down. We didn't use them at all. And now we just repeat that process over again. Well, we got to do negative 2x squared right here to divided by x. And we get negative 2x, so that should go above the x term. And we can put that negative 2x in green right there. And then negative 2x times both of these two terms, x and 2, gives us negative 2x squared and negative 4x. And then we're going to subtract both of these from what's above it, and we get both of those. The first one to be 0, a 5x from the second one, and then the negative 2 gets brought down. But then we need to complete this process one more time. We need to go x into negative 5x, or 5x, and we get 5. And then 5, we are going to be multiplying by the x and the 2 that we have on the originally dividing by, and that gives us 5x and 10. When we subtract those bottom two numbers here, 5x and 5x, negative 2 and positive 10, we get negative 12. And that leads us to our next answer, and that is going to be what you see at the bottom here. This equals what we have started with in the problem. And so our quotient is x squared minus 2x plus 5. Our remainder is negative 12 right here. And then x plus 2 is what we divided by. This problem is our final example, and we're going to be dividing 2x cubed minus x squared plus 2x minus 3 by x minus 1. And I have my long division set up to the right as it would be set up in a normal problem. The first thing we're going to be doing is doing 2x cubed divided by x, and that is going to give us our first answer of 2x squared. And that 2x squared is going to get multiplied by our two numbers in front, x and 1. And we get 2x cubed minus 2x squared. Our next action would be then to subtract from there, and we get 0. Negative x squared minus negative 2x squared equals positive 1x squared, and our 2x gets brought down next. And that cycle is going to repeat because we're going to go x into 1x squared. That is going to be going into it 1x times. And so then 1x is going to get multiplied by what I have so far, and in front, x negative 1. And that gives me my next two answers of 1x squared and negative 1x. So that I'm going to subtract like before, and that gives me an answer of 0. And then 2x minus negative 1 is 3x, and then negative 3 gets brought down after that. So that is most of the problem already done. And we just have our final part to go. We're going to do 3x divided by x, and that gives us 3. And we do 3 times x and 3 times negative 1. And that is going to give us our answer of 3x and negative 3. And you'll notice that these are identical. And that's what we're looking for if there's going to not be a remainder at all. And you can see that our remainder ends up being 0. So this is a special sort of problem because now that we know the remainder is 0, that means that what we divided by, x minus 1, and what we got as an answer, 2x squared plus 1x plus 3, are both going to be factors of the original polynomial up here at the top. And there's going to be two different ways to write that out. I can write it out in green using division, but I can also write it out using in orange by just writing out as factors. So I have my original dividend, which is in orange, and I have my quotient in the first parentheses and my divisor in the second parentheses. The quotient and divisor are both definitely factors of the dividend because you can divide by either of them and get an answer of 0 for your remainder. And that covers all you'll need to know about long division for polynomials.